Okay, let's jump right into this explainer and look at how modern software avoids, well, collapsing into total chaos. Today we're talking about the absolute backbone of modern software engineering, Git and version control. So whether you're a seasoned engineer or you're just kind of curious about how massive global teams manage millions of lines of code without constantly overwriting each other's work, you are definitely in the right place.
I mean, we've all felt that sinking feeling, right? You know the one. You hit save, or maybe you accidentally delete the wrong directory, and suddenly, poof, hours or even days of hard work just vanish. Or, oh man, even worse, you realize you just overwrote a colleague's critical file. Well, that feeling right there, that perfectly frames the universal problem that version control was built to solve. We're talking about a massive problem of scale, safety, and collaboration.
So first things first, what exactly is this? Basically, version control is the practice of controlling, organizing, and tracking different versions of your computer files over time. Honestly, the best way to think about it is like a time machine for your code. It lets developers seamlessly revert changes, mitigate the damage from those inevitable mistakes, and literally travel back to any specific point in a project's history. You can see exactly what a file looked like on, say, a random Tuesday 3 months ago. Here's our quick agenda for today. 1. What is version control? 2. The birth of Git. 3. Inside Git's object store. 4. Basic Git commands explained. 5. Branching and merging code. And finally, 6. Why this all matters. All right, starting with section 1, what is version control? The time machine for code. Now, take a look at the stark contrast here between older centralized systems and the modern distributed approach. Back in the day, with a traditional client-server system, you absolutely had to have network access to communicate with a central server just to view your history or do basic operations. But distributed version control, it changed the game entirely. In a distributed setup, every single developer has a full local copy of the entire repository right on their machine. That includes the complete history and all the version tracking abilities totally independent of network access. So every developer's working copy is effectively a remote backup. Talk about inherent protection against catastrophic data loss. Moving right along to section 2, the birth of Git, speed, integrity, and thousands of branches. So Git was actually born back in 2005 out of sheer necessity. Linus Torvalds literally needed a tool that could handle the immense, sprawling scale of the Linux operating system kernel, and his design goals? Uncompromising. He demanded incredible speed, rock-solid data integrity, and support for distributed, nonlinear workflows. We're talking thousands of parallel branches running simultaneously on different computers all over the world. These monumental contributions to open source eventually earned him some massive accolades, like being inducted into the inaugural Internet Hall of Fame and winning the Millennium Technology Prize, both in 2012. But, despite the absolute genius behind the architecture, Torvalds kept his signature sense of humor about the whole thing. When someone asked him what the name Git actually meant, he gave this famous, highly relatable explanation. He basically said it can mean global information tracker when it works and the angels are singing, or, well, a goddamn idiotic truckload of garbage when it breaks. It brilliantly captures his self-deprecating nature, doesn't it? It just goes to show that even the tools we build to solve our biggest headaches can occasionally be a massive headache themselves. Jokes aside though, make no mistake, performance was the ultimate key to Git's wild success. Just look at this chart highlighting some performance tests done by Mozilla. It shows that fetching version history from a locally stored Git repo is an order of magnitude faster. We are talking up to 100 times faster than trying to fetch it over a network from a remote server. Because everything lives locally on your machine, your everyday common operations happen almost instantly. All right, section 3. Inside Git's object store, how files become history. Now this is where it gets really cool. Git transitions a file through this fascinating little micro-narrative within its object database. So first, the raw content of your file becomes an immutable blob. Git identifies this blob internally using a cryptographic SHA-1 hash, which is basically just a unique digital fingerprint for that exact piece of text. From there, it gets organized into a tree object. Think of a tree like a directory that points to all those different blobs. Next up, a commit object permanently stamps that tree right into history, adding in a timestamp, your log message, and a link back to any parent commits. And if you want, you can use a tag to digitally sign or highlight a specific release. Oh, and finally, because storing every single revision of every single file would eat up your hard drive, Git uses things called pack files. These are ziblob compressed bundles, kind of like a zip file, that use delta compression. They only store the actual changes between files, which ends up saving a massive amount of disk space.
Next is Section 4, Basic Git Commands Explained, the daily developer routine.
So this sequence right here, this is the fundamental everyday rhythm of a software engineer. First things first, you run git clone to copy a remote repository directly on your local machine. Then, as you're in there tinkering and making changes to the code, you'll use git status to check in on what's going on. Honestly, this command is an absolute lifesaver. It shows you modified or unstaged files in bright red. Once you're happy with your work, you just use git add to move those red files over into the green staging area, basically teeing them up for a commit. Finally, after you actually commit that work locally, a quick git push sends all your changes upstream to the remote server, making them available for the rest of your team.
Which brings us to Section 5, Branching and Merging Code, Managing Parallel Universes.
Now, even though Git allows for virtually infinite parallel branching, teams still need real strategies to avoid total chaos. Enter the concept of trunk-based development. See, instead of isolating your work on a separate branch for weeks or even months on end, a lot of modern teams work directly on a single primary branch, usually called the main or the trunk. They rely on small, really frequent commits to constantly merge their changes back into that main line. It's a brilliant strategy, really. It keeps the code base in a constant release-ready state, and it drastically cuts down on those massive, catastrophic merge conflicts that inevitably happen when you try to jam huge amounts of code together all at once.
And lastly, Section 6, Why This All Matters, Scaling Collaboration Securely.
Let's bring it all together. By giving us instant local access and a complete, basically tamper-proof history, distributed version control takes what used to be a highly stressful, chaotic, overwrite risk scenario and transforms it into a secure, highly collaborative environment. First off, it inherently protects against data loss, simply because everybody has a full backup on their machine. It also makes debugging so much easier since you can isolate the exact specific commit that introduced a pesky bug. And ultimately, it allows literally thousands of developers spread all across the globe to collaborate, experiment wildly on their own branches, and maintain total accountability over one massive project, all without ever stepping on each other's toes.
All of this leaves us with a pretty fascinating thought to consider. If a decentralized system like Git can perfectly track, flawlessly merge, and protect the unbelievably complex logic of global software projects, how might this exact same nonlinear, distributed approach revolutionize collaboration in completely different fields? Seriously, think about it. From drafting massive legal documents to publishing books, the possibilities are just vast. Anyway, thank you so much for watching this explainer on the Tech Canvas. Complex ideas, clear pictures. Be sure to follow for more.